And good morning, everyone. We are here together for a webinar, Introduction to Prespective. My name is Andreas Huvenaars. I'm the COO of Prespective, and my colleagues Daniel Venego and Matthijs van den Wegen will be joining me today, where Daniel will be giving a short introduction to Prespective, and then Matthijs will show you a live demo. During the webinar, you can post some questions in the Q&A, and afterwards, or during the webinar, we're trying to answer them, and afterwards we'll have some room for additional questions. So I would say enjoy, and I'm going to give the presentation to Daniel.
All right, thank you very much, Andreas, for the introduction. I'm all set. I hope everyone can probably see my screen and can hear me loud and clear. If that's not the case, please let us know, of course. So yeah, thank you very much for having us and for giving us a little of your time so we can introduce you to our solution called Prespective. Maybe some of you are already familiar with Prespective or with Unity in some way. So some things talked about here during this session you may already know. But in general, this webinar will focus on an introduction to our software and on how to use it and implement it in your workflow, and of course, show you the basics of the software itself in a short demo. We are currently working on some new webinars as well that will focus on more advanced features of Prespective, such as discrete event simulation. So if you have any interest in that, please make sure to keep an eye on your LinkedIn, to our LinkedIn page and to our website. A quick look at the agenda. Andreas already mentioned it, but we will try to make sure we will finish up within the hour, and we will focus mainly on two things. A short basic 10-minute introduction to Prespective, where I will focus on the high-level use cases and which problems it solves, and some success stories we would like to share with you. After which my colleague will give a 35-minute demo of the basic features of Prespective, and at the end, to wrap it up, and if needed, a Q&A section. As Andreas mentioned, you can send your questions through the Q&A function of this webinar, which will be followed up by our moderator. And you can find the Q&A at the bottom of your screen. But first, let me introduce myself. My name is Daniel. I'm the sales manager of Unity 40, which is the company that develops Prespective. As said, I will talk a little bit about Prespective before the demo starts. And also present and much more important than myself for this webinar is the attendance of my colleague Matthijs. He's a software engineer that works on the core of Prespective and is also a key member of our Academy team. And he will be the one that's going to demonstrate you Prespective later on. Our Academy team makes sure that our users have access to proper documentations, video tutorials, but also they are also trained to demonstrate Prespective and to understand the pain points of our clients when it comes to development cycles. So as said, Prespective is a product of Unity 40. We're a company that develops software solutions for industrial purposes for almost 15 years now. Started as a startup at the university in Eindhoven, we quickly became suppliers for big companies as Siemens, Bosch, Shell, and ASML. Our core business back then was to develop and implement simulations and product configurators to the high-tech industry. And in 2017, we started with the development of a standalone software application that we called Prespective. And we did this because we saw a growing need for virtual prototype and digital twin solutions. And instead of developing a new engine from scratch, we decided to build our toolset on Unity 3D, which is a gaming engine. And the reason for that is that it allows users to develop in real-time 3D and to not be technically and economically be locked in with a certain software vendor, but to take advantage of the open nature of the engine. Prespective is now a couple of years in development, and this year we had our first official version released after a successful beta program that was used by numerous companies and users. So now, 3 years later, Prespective is a proud verified solution partner of Unity. And what that means is that on the one hand, our solution is verified by Unity's technical team, and on the other hand, can be sold by Unity's sales team. We work very closely on serving industrial clients with our joint solution, and working closely on delivering a robust tool set for the industry. We work for and with a lot of companies you may recognize, and we love to explore the possibilities of working with you or your company as well. Three things I would like to remember that you remember after this presentation. What I hope you will learn from this webinar is that solutions like ours are in high demand because industries are changing. Development cycles must be shorter, safer, and more agile. And this asks for a new kind of working. And with the use of Prespective and Unity, we help clients achieve reduction of total cost of ownership with up to 30%, because company departments like engineering, mechatronics, software development, and even sales and training can work parallel instead of sequential. And because of this exact same argument, in combination with less physical prototypes, clients report a much faster time to market and thus saving enormous sums of money. And last but not least, I understand that starting with digital twin software or virtual prototype software can be considered an open field where you maybe don't know where to start. And that's why we say that the proof is in the pudding. So we gladly offer you a free trial of our software, and are also very much open to the idea of setting up a call with you to discuss your exact needs and wishes and help you find your way. Just reach out to us, and we are happy to help. Okay, so very quickly, an introduction to the tech behind Prespective. Our promise is that with our software, you can build a realistic digital twin that behaves exactly as it would in the real world, using advanced physics that are developed for industrial purposes, numerous standard interfaces to, for example, control software and other data sources. And we do this mainly for the industry in the verticals manufacturing and infrastructure. And the reason for that is that these industries typically have a very expensive development phase with high chances of failure. And in manufacturing, we focus on companies that build machines or production lines. And in infrastructure, you can think of companies that build bridges or tunnels, for example. Basically companies that have moving objects or parts in their system or products. And what we see is that a lot of these companies are wasting tons or even millions of dollars in time and materials and resources during the development phase. And the way a lot of companies work is that their engineers develop a machine or a system of some kind in a CAD software tool, after which they immediately start producing physical prototypes. They have absolutely no idea if the drawings will work in the real world, so they already know that there are going to be a lot of iterations with expensive prototypes. And the problem with that is that other disciplines within the organization, for example, as mentioned, software engineers have to wait to start writing the behavior of the system. And of course, when they do start, they encounter all sorts of mistakes that have been made during the development phase, so they have to start again, and so on and so on. And meanwhile, they have a very anxious client that is waiting on their system and demands that everything needs to speed up. And that, of course, is very stressful and not at all efficient. So with new technologies like ours, and of course Unity's, companies are now able to do this exact same development cycle, but in the virtual world. In short, we call this virtual prototyping. So far less physical prototypes, wasting of materials and time, and much more a multidiscipline way of working. With Prespective, we offer users a way to build and validate your system. And the keyword here is validate, because we validate the virtual prototype before the physical version is built. So the result of that, of course, is the big selling point of our product, because we promise results up to 30% less TCO, total cost of ownership. And we recently did an intense case study together with Unity for our client, the MTC, based in the UK, in which the client stated that they could develop up to 65% faster using Unity and Prespective than they currently could do, and that's amazing, of course. So the way that we operate is that our tooling allows users to import their data, mostly as a CAD model of some kind, and connect that to the actual control software, and basically make it come to life. So the real control software is part of the system. Sorry, I think my mic was not reacting properly. So let me start over at the slide before. Yeah, so I was here. As said, the real control software runs the model, and they can use it to make, for example, conceptual visualizations, for example. This is a very big use case because this is a visualization that users usually can set up in a day, and from there on can showcase it to all kinds of stakeholders, including the customers and colleagues. And you can basically use it for design reviews, for marketing and sale purposes, and it's the groundwork for use cases later on in the development cycle. And the great thing is that you can even add a certain made UI to it. So it's not only usable by tech people, but also, for example, for people in sales to really show customers how the end product will look and how it operates. And you can even send it as a link via our WebGL functionality. After setting up your conceptual visualization, a lot of our customers use Unity and Prespective for things like throughput analysis or virtual prototyping. There it is, which basically enables users to test their throughput and to measure if they can do it with less resources. Or for example, see how the system will react if throughput would be sped up, or what happens when you add an extra conveyor belt or a robot arm. And this way users can measure the total cost of ownership, and this can really work as a sales accelerator for our users. Yeah, and as I said, virtual prototyping is the use case we see the most among our customers. And I think I really covered this already in the previous slides, but the main selling point here is that it cuts the amount of physical prototypes, and it enables a shorter time to market, which in itself also has a big impact on the return on investment. So yeah, those are the main use cases. But of course, there are many more use cases that you can use with digital twin technology. You can imagine that if you have a certain system set up in your virtual world, you can also start with planning optimization and collision detection. And that's the power of Unity, of course. Users can place virtual sensors, connect to external data, for example, IoT data, and track everything in the virtual world and use this data to validate assumptions or throughput analysis. So a quick look at a couple of success stories that we are allowed to share. First of Festo, a big multinational automation company, and Festo uses Prespective to import their own library of components and products, including real-life behavior, and provide that to the customers using a variety of parameters. Customers can try out Festo products before ordering them, which is very useful, of course. So you can think of this case as sort of a configurator for sales purposes. LAN handling technology, they use Prespective for testing their machine lines. They focus very heavy on the material handling part of the system, and the biggest KPI for them lies in the fact that they want to optimize their throughput. Of course, this is very difficult to do in the real world, so they use Unity and Prespective to do this. And what Prespective's biggest sell in this specific case is that we offer an extra physics layer on the physics that Unity uses, that combines discrete event simulation and 2.5D physics for even more precision. The science behind that is pretty complex, so if you want to know more about that, then we can connect you to the right people that know more about this than myself. One of Toyota's subsidiaries, Van der Lande, is a company that is a world player on baggage handling system, as seen on the video here. It's hard to see, but there are red and green lines that show what the virtual sensors see. So they use Prespective for setting up this entire virtual environment to debug the machine and see if the software worked correctly. And once set up, they just let the machine run for hours and hours and pretty much wait and see if something happens that they did not anticipate on. And of course, debug it in real time. And what's pretty awesome is that Unity allows them to use certain assets in the scene as well, such as avatars and luggage. And on the video by the left, by the way, you see that the virtual model is actually hooked onto the PLC. So yeah, that's it for me. As said, in the beginning, this is just a very brief introduction. If you want to know more, please visit our website or ask for a private, more in-depth presentation of Prespective. And we are happy to set that up. Also check out our free trial and choose our online academy as your guide to the first basic steps and let us know if you need any help. So with that, I think I can turn it over to Matthijs.
Okay, so let's see if I can share my screen. Yes, I can. Great. Okay, so this should be able to be hidden like this. Okay, great. So, hi, I'm going to show you how to build this 3D printer I've set up here. I have an external controller running in the background. It's a TwinCAD ADS connection, and that's controlling this simulation right here. I have a simple demo code set up here, and that's currently controlling the 3D printer. And I'm going to show you how to do this fairly step by step. So let's start with going to the very beginning of the project, and that's going back to the initial import. So I'm going to the original imports. Let's not save my changes. Okay, so this is how the printer was imported originally, more or less. And it comes like this. So there is a bunch of elements. Oh, there are a bunch of them disabled still. There are a bunch of elements in the model, and they aren't always organized in a way that you would want them to be. And we have developed tools to help you organize your project to begin with, because many of these pieces of the model you do not need for the actual simulation. For example, models that have a lot of screws, or these blue corner pieces, for example, they are not relevant to the simulation itself, and you may want to hide those or group them under a separate parent object to keep them out of way while you're actually working on the simulation itself. So we're going to begin with that first. And we have created, as I said, several tools for that. So let's start with trying to find all blue objects, for example. None of these blue objects are relevant to our simulation. And for that, we have created the mesh query. And the mesh query is a tool you can use to find components of your model that are relative to a specific part. So I'm going to select this blue corner piece here, which is this object. I'm going to drag this in. I'm going to say, okay, I want to select every object that has the same material, the same blue material. I click select similar, and it now selects all these pieces with the same blue material. And that's a fairly easy way to find, in this case, the blue objects. Maybe you only want to select the corner pieces. In this case, I can say, okay, I want the object with the same area, mesh area, and the same mesh volume. Select similar. What does it find? I have still select this thing, still select, so that's not going to work. Click again, select similar, and there it is. It now finds these 4 corner pieces, which are exactly the same. And that's how you can use this tool to find objects that you may want to group together. So let's say we wanted all the blue pieces. Okay, select similar, there they are. We can now actually group them under the same parent, because these are all parented under their own separate parents, where they have their name with the object where the actual mesh is onto. But we want to group those under one parent to be able to hide it easily. Then we have this grouping tool. Everything that is selected now will be grouped under the same group as soon as I click this button, group selected objects. I'm going to call this blue objects for now, and I'm going to click group objects. And now at the very bottom here, I have this object created, blue objects, which holds all these blue pieces in one. I can now, here on my right, I can now close this group, And all these separate parts here will be packed into one. So this makes sure that if I now select one of these objects, all the blue objects are selected, instead of before where I selected the blue corner piece itself, it only selects the blue corner pieces. It now sees it as one entire mesh. However, this is done in a non-destructive way. That means if I now open the group, all my original meshes are set back to their original states in this shared parent. And the same goes for if I want to entirely disband my group, they all get set back to their original parents as they were before I grouped them initially. So that's how I can create groups. And I have created three different groups. In the next scene I have set up where I'll be going to next. But first, unfortunately, this model came with a slight error in it, and I've marked this error red, as you can see here, because this object has the wrong pivot point. You want to be able to rotate this over its own axis, and currently the pivot is offset. So we want to fix that. Instead of sending the model back to the model maker and waiting for a few days, maybe even weeks, we can now fix this on our own in a matter of minutes. And I'm going to show you how. So let's first set the pivot of this gear object here. I'm going to disable this now for clarity so we can see this. Okay. We're going to set the pivot so that it actually rotates from the center of this gear instead of the point it's currently set to. And for this, we're a pivot where, and for that, we're going to need to align this pivot point. So we're going to select the pivot object and we want to align its transform, and we want to align it to this gear object right here. That's this one. We're not going to align it to the pivot of the gear because that's the pivot we don't want to use, but we're going to use a 3-point circle to position the pivot. And we now get these 3 points here. I'm going to turn on shaded wireframe so I can see the vertices on the mesh. And we're going to position these points on the circle shape here on the cylinder. And let's rotate to see whether they are positioned correctly. And this seems to be okay. So this now draws this circle and it generates this blue line, which is the normal of the circle positioned on the center of the circle. And that's the exact point where we want our pivot point to be so that this gear rotates around that point. So we're going to align the transform pivot of the empty game object, which is this here, to the center of this 3-point circle on the gear object. And we're going to select only align the position because I want to keep the rotation of this point as it is. And as click apply alignment, and it now jumps to the center of this circle. So I now have my pivot point still here, but the empty game object is now positioned in the position where I want the pivot of the gear object to be. So the next step is to actually set the pivot of the gear object. So I open up my pivot tool and I select the pivot of the object I want to use, which is my pivot object. And I then select the object I want to set the pivot point to. And I set move and rotate in this case. You can either move or rotate or do both. I'm going to do both. And I click change pivot. And it's as simple as that. And now my pivot of this object has been changed and it now rotates over the axis it actually needs to rotate, as you can see here. And that it was done in, well, if I do it quickly, I can do it in, I think, 20 seconds instead of what could be weeks in the worst case. Next thing we need to do is we need to align this object back onto this axis right here. And we use a very similar procedure. I'm going to delete my empty pivot object because I no longer need that. And I'm going to open up my alignment tool again. But this time I'm going to align the gear object onto this this axis, which is this object, okay? And I'm going to align the transform pivot of the gear, which is now set properly, to once again a 3-point circle, because the pivot of the axis here is not at this point, or nor on this hard line of this axis, but I'm going to use the 3-point circle again. Okay, my points are here, so I'm going to drag these over like I did just now. Just drag them here, and then I'm going to reposition them more precisely. Let me focus so that I can zoom in more. Yeah, let's position these. And yeah, that seems to be okay. Okay, great. And then I'm going to align only the position and not the rotation, because as you can see, the blue lines of these two objects we want to align do not match. So if I now would align by rotation, these two lines would be placed on top of each other, and this gear object would rotate 90 degrees over the z-axis in this case. I don't want that. I just want to align on position, and there it is. Okay, so last thing I'm going to do is now simply eyeball this, so this matches the rubber band like this. Oh, that's the wrong object. I need to select the parent, otherwise the screw doesn't come along with it. And this now sits nicely on top of that axis. So this is how you can fix small errors in your model yourself without need of other people working on it. Okay, so let's jump to the scene where I have cleaned up the entire model. Okay, let's not save this. And here it is. Okay, I have now my 3D printer, and I have created 3 groups. The support objects, which is mainly the blue pieces, with the exception of a few. Oh, that's the wrong button. This. And I have the frame, which is also not necessary for my simulation. And these are the parts that are actually taking part of this simulation. So these are in their own group, the printer components, and I have arranged them in a way where I can easily find all of my components. So I'm going to turn on back the frame because I think it's just nicer to look at. But you can do whatever you like, of course. And now it's time to rig the kinematics of the printer. Let's start with this motor. This motor rotates this gear, which drives this rubber band, which in turn drives this axis here. And on the other hand of the axis, there is another rubber band, that's this one, which makes the printer head move along the z-axis, in this case in the scene, but it's the x-axis in the printer, I believe. So let's start at the very beginning, and that is by making sure that this gear can actually rotate. And for that, we're going to rig it with the kinematics. Before you can apply kinematics to anything, you need a kinematics controller. So at the topmost parent, in this case, the 3D printer object, I'm going to add a kinematics controller, which manages all kinematics that it has parented underneath it. You can set this up once and forget about it entirely, unless you need to do some debugging, but this is managing everything on its own from now on. So I'm going to go back to my gear, and let's see, this object, I want to assign a wheel joint to this so that we can rotate over a plane. It is spawned with a default radius of 1 meter. I'm going to set this back to 1 centimeter for this simulation. And then I need to define the plane which it's allowed to rotate over. In this case, the plane is not properly aligned. So let me change it. I have the axis direction and the forward direction in the wheel joint here. And let's say the axis direction, we want to set that to forward. Yep. And then the forward direction is right. This is okay. It's now aligned nicely. So if I now enforce this to work outside play mode, which means that I do not have to press play within Unity here to make it work. This now rotates over this axis, but should no longer rotate over this axis nor over this axis, as you can see here. And it now actually has been limited to this plane. So that's the wheel joint setup. Then I have the axis here, which also needs a wheel joint. So I'm going to zoom in to this point where the pivot of this object is set. And I'm going to also add a wheel joint to this game object. I'm going to do the same, bring the radius back to 1 centimeter, and I need to reposition the plane. And the axis direction I'm going to set also to forward, and that's not the right direction for this object, as we can see. Let's set this to right, and there we go. Yes. Enforce this, and this works, but this no longer rotates. Okay, great. Then, next thing we need to do is we want these gears to work together. I'm not going to simulate the actual rotation of the rubber band. We could, but I'm going to save that for another time. And we're just going to make these gears rotate in a one-to-one, how do you say that? Well, basically, if this rotates one revolution, this goes one as well. So let's go back to our wheel joint here. And I can see that my wheel joints are set on these objects because of these icons. This is a wheel joint, and this means that there is a kinematic transform on it, and of the type wheel joint in this case. And we want to create a connection, relation between these two. And we can do that by clicking create a new leading transform relation. And this opens this menu. And it first asks you, okay, with which other kinematic transform do you want to create a relation? And this will be our other wheel joint. So I'm going to drag this in here, and it now created a relation. So if I now rotate this object, you can see that the wheel joint here on this axis now starts rotating along with it. However, it's rotating in the wrong direction. We want them to be rotating in the same direction, and now rotating opposite to each other. And we can easily fix that by clicking reverse the direction, and it now rotates in the same direction. It's as easy as that. So we have now a working relation between these two wheel joints. Next thing we want to do is we want to move this rail over this rail here, because as soon as this object here rotates here, I'm going to turn off my frame, it makes it easier to see. As soon as this rotates, this rubber band will drive this component over this rail here. So we want to limit the motion of this object over this rail. I can now still rotate, move it in any direction I want, and we're going to limit that. And for that, we need a prismatic joint. So I'm going to add a prismatic joint under here, prismatic joint. But a prismatic joint needs a spline to be, which describes the path it's allowed to move over. I need to set that here. So I'm going to need to create a spline. I'm going to do utilities, create a spline, and it now creates a new spline on my scene. And I'm going to drag this under the same component here where the prismatic joint is. I'm going to rename this prismatic spline for now. Okay, I'm going to set this to 0, 0, 0, and there it is. And then I need to align this spline in the way that it describes the path of this rail. I could use the alignment tool, but it doesn't need to be 100% in the right spot, because the motion of this object will be relative to the spline, meaning that I can position the spline anywhere in the scene and it will still follow the path of the spline, but we want to have it in the place where it actually moves, just to make just to keep things clear for ourselves. So I'm going to rotate to minus 90 degrees, so that it now at least follows the same line as this rail. And I'm then going to simply eyeball it for now on this rail here, so like this and like that, so that's in the center of this rail. And I'm going to bring in the second point because it's all the way over here and that's way too far. I'm just going to drag it in for now, like this, so that it approximately matches the rail. We can later exactly set the limits of this prismatic joint, but I'm going to set it for now, here for now. So I have now my spline set up, and then I'm going to assign the spline to the prismatic joint. And if I now enforce this, this object is now limited to my spline. As you can see, it can no longer move past the spline, nor can it move in any other direction than the spline allows it to do. So that's how you set up a prismatic joint. Now I said we can further limit the spline to match the exact movement of the component. So let's say the hard limit of this component is right there. I can now say, okay, the current position of my object on this spline is the outer limit, the 0.1 limit. So I select 0.1, click update, and there it is. It now jumps to this position. And I can do the same for the 0.2 limit. So let's say it's over there, limit, and it now can no longer move past these points. So let me undo this so that it realigns with the head. Yeah, okay, great. So I have now set up my prismatic joint. Next thing we need to do is we need to create a relation between this axis here and that prismatic joint. So I'm going to go to this wheel joint here, which drives the rubber band. And that's this wheel joint, and we're going to create another relation with this. So we have the old relation with the wheel joint still in here, but I'm going to create a new relation with the prismatic joint, which is which we can see that this is this game object here by this icon. I'm going to drag this in. If I now rotate this wheel, you can see that it now drives the prismatic joint. And notice how as soon as the prismatic joint hits its limit, I can no longer rotate the wheel joint either. They are now actually limited to each other's limit. Okay, let me undo it again so that I cannot. Okay, let's not undo it then. I'm going to simply put it back into place for now by eyeballing it. You can use the alignment tool for that, but to keep things flowing, I'm just going to eyeball it for now. So if I now rotate this wheel joint here, this prismatic joint should be moving along with it, as you can see here. So we have now rigged the kinematics for this part of the simulation. Next thing we need to do is we want to actually have it be driven by something, and in this case, the motor. So it's this object is a stepper motor. So I'm going to add a stepper motor to this object. I'm going to go to standard components, motors, and driven stepper motors, add the component. And the first thing it asks for is a wheel joint to drive, and it has found the wheel joint that we have already set up. If it cannot find a wheel joint, it will generate a default one on the same object, but it now has detected the wheel joint already set up here. And I'm going to create a control panel. The control panel is needed if you want to control the game object not using an external controller, but from the scene. And let's do that for now. We're going to hook it up to the external controller later. And if I now click run, it throws an error because it tried to rotate in the wrong direction, because it already is at its hard limit here. It can no longer rotate in that direction. Let's try again, reset the error. Start, and you are not willing to rotate because you are at your very limit, I think. So let's set them here for now. Let's try, yeah, there we go. And it's now driving the prismatic joint here, and it will now go back to its error because it has reached a hard error. Oh, sorry, a hard limit again. And then it can now rotate back this way. So that's how we set up our motors to drive our kinematics. Okay, so we have 3 motors here. This one to move the head over this axis. The head didn't move along with it, however, because it's parented underneath another parent, because we need another set of splines to actually simulate the movement over this plane. We have the second motor here, which drives the head over this axis eventually, and we have a motor down here which moves the plateau up and down. So let's go to my kinematics scene. Let's not save this. Okay, and here I have fully set up my kinematics, and I'm going to show you by going to play mode, and I have set up a control panel here, and I can set this to move and that one to move, and you can now see that the printer head actually moves, and the same goes for the plateau. This can move up like this. So the last thing we need to do now to complete this simulation is to connect it to an external controller. And for that, we need a logic controller. We can find this under logic and add the simulator. This is the component that links the simulation to an external controller. This one is a manager, similar as the kinematics controller was for our kinematics. And to control a, in this case, a stepper motor, we need a logic component for the individual stepper motors. So I'm going to add a logic component for the stepper motor. Under the motors stepper motor, there's also the logic component. And this asks to select a driven stepper motor. I'm going to parent this under the simulator, very similar as to how this needs the kinematics parented underneath it. The logic simulator also needs the logic components parented underneath it. And let's assign a stepper motor. So I have here a stepper motor on this game object, that's the body, and I'm going to drag this body into here. And it now has this body connected. Then you need to set up these settings, and I'm just going to do that quickly. That's how you want to connect the components to the external controller, driven stepper motor, the address that it needs to look for. These are the IOs for this component, and I'm just going to use a single motor for now. Then we need to, so that's the logic components in this case set up. And then we need to set up the logic simulator, and we need to add a name. So I'm going to call this printer sim. We need to add an XML file path where it will write our IOs to. So I'm going to call this demo printer plc.xml. The server is the printer server. And then my IP address, which is found in the TwinCAD settings. So I go to TwinCAD, and this is my local IP address. I need to add the port for the PLC. I'm going through this fairly quickly. You can find all this in our documentation as well as our online tutorials. So, but I'm just going to go this quickly to keep things going. And then I can export my XML because all my settings are now filled in. This now generates an XML with our IOs. I can open this XML file, and it will now show me all my IOs that I've defined for my simulation. So I have the driven stepper motor logic here, and it has an IO called iVelocity, an iPosition degree, an iPosition step, etc., etc. So this is now set up. Then if I go to my PLC, let's close this because we want another. Oh, I had needed to close it first, but let's open up Visual Studio. I have set up an empty project. All right, let's load this in. I can export my files to this project from the Unity scene. So I need to find the project path, and that's this path here. Then I'm going to go back to my project and then need to fill this in here and then export my configuration files. So that went all fairly quick, but the thing it does, in these two folders, the GVLS and the POUs, it now generates files for my simulation. So if I add an existing file, it now finds this file. And also under my POUs, it finds the file for the driven stepper motor, which is in this case the only logic component we have assigned to our simulation. I am using, by the way, an extension to Visual Studio rather than the dedicated TwinCAD program, because TwinCAD's UI is bugging out on my system and I cannot seem to fix it. So I highly recommend you using that program instead of the Visual Studio extension, because it all has dedicated buttons for everything, and this has not, what makes it a little bit more tedious to work with. But while saying that, I have logged into my PLC and I have now all these values for my motor live. So let's go to play mode, and this will start up my simulation. So it didn't throw any errors, which means it connected successfully. And I can now, let's set this to the right and on the left. I can now see the values of my motor coming in live if I did everything correctly. So let's bring this in. So if I now go to my motor here, we should, if I, for example, let's set a, let's close you now. I'm going to set a value for continuous. Let's set it to true. Right values, there it is. It now starts moving, as you can see here. I'm going to set it to false again. Right values, and it stops. So we can now see that our simulation is working with the external controller. So that brings us to our last scene where we started off with, actually. So let's go back to here. And this is the same simulation, but then set up with all three motors. Let's close this down. It's probably going to complain again, isn't it? Oh, it's not. Okay, great. And then we can open our printer project that I have set up and showed you at the very beginning. And let's run this again to see the final result once more. Okay, activate this. Yes, and while you activate, I will go to play mode. Yes, restart. Or okay, and log in. You are in play mode. You had an error. Let's try again. Yep, okay. And then I can, oh, it's actually running already. Ah, there you can see. And we have now everything set up and running as intended. So that's how you set up this 3D printer in a nutshell and fairly quickly. And I'm going to give the presentation now back to Daniel.
All right, thank you very much, Matthijs. I think I'm going to give it back to Andreas because I think he's going to quickly go over the questions that has been asked at the Q&A section.
Okie dokie.
Yes, thank you, Daniel. We've had two questions. I'm answering them at the moment. If anybody has any other questions, you can mail us or post them in the Q&A right now. If you think of any other questions, don't hesitate to reach out to us. There's a question from Björn. I presume this model was originally in a CAD suite. What tool / file type did you use to import this geometry into Unity? Well, we use the Pixis plugin. This is a plugin developed for Unity and is one of the partnerships Unity has. Pixis is able to import all types of CAD data into Unity and get it in several different types of fidelity into Unity. We highly recommend using it. Another question from Marie Sylvan. How can we add dynamics to into this model, or can we run our own dynamic model? We are currently focusing on running kinematic simulations. We intend to do kinetic simulations in the future. And we do support FMUs and connections to other simulation software like MATLAB or Rhapsody. We don't intend to make simulation software in Unity that is able to simulate every thing, but we will be able to give you the connection to other simulation software so that you will be able to visualize simulations run in other software. Let's see, there's some more. Oh, there's a follow-up question. A real-time communication. We strive for our simulations to be in real time, but through the support of, for instance, FMU, functional mockup units, we should be able to, in real time, visualize simulations that have been run in other more expert tool softwares. And question from Mark. Great presentation with regards to throughput analysis. Can the simulation be run at speeds faster than real time? Yeah, great question, Mark. Yes, we can. We are currently looking at running simulations at 3,600 times the real-time speed. The real power of throughput simulations is, of course, running them in higher speeds than normal so that you will be able to quickly simulate and judge a long-term throughput analysis. Hopefully this answers your questions. For the moment, I don't see any other questions. Oh, there's a question from Martijn. Thank you, Martijn. How do you handle CAD revisions on Unity? That is a good question. We currently are developing our own migration tool, which enables you to keep all changes you made within Unity to the model. So for instance, added components or added pivots or added logic connections and update them with the new CAD model. So this is, of course, if the geometry is changed drastically, this might pose some problems, but gradual revisions we should be able to support. A question from Jaco. How much time did it take to make the initial model for the 3D printer? I think Matthijs was the one working on this, and I think, can you answer this question, Matthijs?
The initial model of the 3D printer, I think you mean the organizing of the printer, and that's highly dependent on how you get it delivered by the model maker, of course. Sometimes it already comes organized and then it's good to go. Sometimes it comes with characters I am not able to decipher myself, and then it's a lot of work. And it also is highly dependent on how much parts are there in the model. But using the query tool, you can go through it fairly easily. And this one took me, I think, 20 minutes to fully organize, because it was, to me, not very good organized to begin with. So. Yeah.
And Matthijs, regarding the regarding setting up the motors and all the logic components, how much time do you reckon that would have cost you?
If I didn't talk you through everything I did, I could have shown you how I did it from start to finish. So I think that answers your question.
All right. Follow-up question from Björn. If we can show something on the link to external dynamic systems. I recommend, Björn, that you contact us through email, and we'll get back to you in detail, because this would require, I think, a bit more time than we have right now. But we're happy to answer your question in further detail. Just reach out to us. A question from Jaco: is model maker a person or a tool? There's always a person making or engineering cut files. So the revisions will always be done by a person, and a model maker. I think it depends on. I think it's a person, but I'm not sure if that answers your question. If I'm understanding the question correctly. All right, I see that we're almost at 11 o'clock, and I think it's time for us to finish here. If there are any more questions, as I've mentioned, don't hesitate to reach out to us. We'll try to answer them as quickly as possible and as thoroughly as possible. And I would like to thank you all for your attention. And I would like to thank Daniel and Matthijs for their presentations, and hopefully see you in the next webinar.